This is the tutorial for Chapter 9, Section 5, titled Completing the Square. And so far we've learned two methods to solve a quadratic, and the first one was to graph. And so we saw that the solutions are the x-intercepts. Well, after that, actually, we learned how to factor and solve. But on some problems, you won't be able to factor, and those are ones that have irrational roots. So we have to have another way, and this is one of those ways, completing the square. So the key on this is we want to make a perfect square out of this trinomial. So we're trying to find the value of c that makes this a perfect square. So the way we do that is we take this b term. Remember, our quadratics are in this form, ax squared plus bx plus c. So we're taking the b term right here, and we're going to find out what half that b term is. So we take that number and divide it by 2, and that gives us 9. And so what we see is that the factored form to make this a perfect square trinomial has to be x plus 9 and x plus 9. And actually, instead of x, they used w in this case. So let me go ahead and change that real quick so you can see this. And so going back to this, I've got w plus 9 and w plus 9. Now the reason it works is because if you look at the first terms, w times w makes w squared. And this is a perfect square trinomial the way I've got it, because I've got two expressions that are exactly the same. But take a look at the inside terms. We get 9w. The outside terms make 9w, and that adds to make 18w. So you see how I'm getting this term. Okay, so what's the last term? Well, that's just the product of these two last terms in each of the binomials. So 9 times 9 makes 81. That's the number we need. So basically, you're taking half of the b term, and once you get that answer, you're squaring that, and that gives you what the missing value is. So 81. So c equals 81. Well, here's another example. So again, we're trying to find out what the c value is. So you're going to take this b term, and you're going to take half of it. So you're doing 12 divided by 2 makes 6. Well, then we said to square that number. 6 squared is 36, so our c value should be 36. Let's see if it works. So you see, if we had b squared plus 12b plus 36, that's what we're saying is the perfect square trinomial. It works because if we go ahead and factor this, b times b makes b squared. 12, well, 12, half that number was 6, we said. So 6 and 6, so 6 times 6 makes 36. If you check out the inside and outside terms, we get 6b and 6b, and that adds to make 12b. And so that is that solution. So it worked, and so we see the answer is c equals 36. So on this one, we have an odd number, and this is where it's a little bit tougher, because when you go ahead and do the division, it doesn't go in there evenly. And so what I do is, some people like decimal forms, and that's fine, but I would leave it in the improper fraction form. The reason why is because when you have the improper fraction, you're only dealing with two integers, -7 and +2. So rather than a two-digit number, 3 and 5/10. And so watch what we end up doing here. So we took that -7/2, just like we had before. We weren't able to actually do the division, but we'll leave it this way. And we're going to square this value. So we're taking that -7/2 and we're squaring it. Now when you square it, you've got to square both the top and the bottom. So this makes +49 over +4. And so you see, whenever you're multiplying two negatives, you're going to get a positive. So no matter what, your c term will always be positive for a perfect square trinomial. So you see, it's easier because people can do 7 times 7 in their head and 2 times 2 in their head. 3.5 times 3.5 is going to be a little bit trickier here. We'll have to do a little extra work. That's why we use that improper fraction form in algebra so often. So we're saying that the form is this way: ax squared minus 7a plus 49/4. Let's see if it works. So when we did that, the factored form was going to end up being this: a minus 7/2, a minus 7/2 is what we're saying it is. And it works because we see a times a makes a squared, and then we have the inside and outside terms. So let me move that down just a bit. And so we've got the 2 there. So we've got the inside terms, -7/2a, -7/2a. And so you can see how that adds to make -14 over 2, which makes -7a. So that matches our middle term right here. In the first terms, a times a makes a squared. In the last terms, negative 7 halves, negative 7 halves make a positive 49 fourths, so it did end up working out. So that's all we're going to do with those problems. Again, that C value was 49 fourths. So let's take a look at some actual problems. And so the key on these is, first thing we want to do is to complete the square, is to do exactly that. Half the b term and then square it, and that's going to give you what that perfect square trinomial is. But then we're going to have the factored form, and that's really what we're looking for. So we're going to need what that value is, and then we need that factored form. So let's take a look at some of the problems. So here we have to solve by completing the square. And so what we're going to end up doing is, first thing is, it's all ready for us. We're going to take this b term and divide it by 2. And so that makes negative 2. And so we go ahead and square that number. Negative 2 squared gives me 4. And so that's the number that I'm adding to both sides. So c squared minus 4c, and then plus 4 equals, now if I add 4 to the left side, I also have to add 4 to the right side to keep this equation in balance. So the key thing I needed to do is figure out what that number was so I can add it to both sides. Well, once I add it to the left side, really all I'm concerned with is the factored form. And the factored form is going to be what half the b term was, c minus 2 quantity squared equals, and then I add these two numbers together, I get 25. So the reason why we did this is to use this little algebra trick so that we can take the square root. What that'll do is it cancels out the squared symbol. And so all I'm left with is that c minus 2 equals, now here we have a square root of 25. There's two numbers that can make it, either positive 5 and positive 5 or negative 5 and negative 5. So we have to show both, plus or minus 5. So then we go ahead and add the 2 to both sides, and we have two problems to set up. We have 5 plus 2, and we have negative 5 plus 2. So we'll go ahead and collect both terms there. So we have 7 and negative 3. Those are the two roots. They work because when we go ahead and plug 7 in for c here, we get 49 minus, and then 7 times 4 makes 24, or I'm sorry, 28, and that does subtract to make 21. We can also plug negative 3 in. So negative 3 squared makes 9. And then negative 4 times negative 3 makes positive 12. And that also adds to 21. So you see how both those answers end up working. So on this next one, the first step was already done for us on this problem. The first step is always to isolate the ax squared and the bx term. So move that c term that you have over to the other side if it's not a perfect square. So we've got r squared plus 8r equals negative 13. So I go ahead and do what I had done before. I need to find out what it is I need to add to make this a perfect square trinomial. So 8 divided by 2 makes 4, and 4 squared gives me 16. So that's the number I need to add. So it's going to be r squared, and then plus 8r, and then plus 16 equals negative 13 plus 16. So I go ahead and factor. So again, the key is on the left side is the factored form. R plus, and then whatever half the b term was, r plus 4 quantity squared equals, now this time I needed what that number was to complete the square because I need to add it to the right hand side here, and that makes a positive 3. So I use that little algebra trick. I take the square root of both sides, and that's going to cancel out the squared symbol. And so I go ahead and I'm left with r plus 4 equals plus or minus the square root of 3. So the square root of 3 is not perfect, so we're going to have some irrational roots. So this is a great example of one that you could not factor. So if you only had factoring as your method and graphing will give you a pretty close idea about what it would be, but you wouldn't be able to figure out exactly what it was. Well, the same thing with factoring. You could not factor this because it's not a in order to factor, you have to have rational numbers. You have to have fractions, and we don't have that here. So these are irrational roots. So we set up an equation that looks like this. Negative 4 plus the square root of 3, and we have negative 4 minus the square root of 3. So this is called the exact answer here. So we're going to approximate what this square root of 3 is. We'll use the calculator here. So we just do negative 4, and I'll make that negative there, and then plus the square root of, wants me to take that square root first. Let me clear this. Let me find out what the square root of 3 is. It's about 1.7 There it goes. That's how we do it. So let's go ahead and try this one more time. It's about 1.73. So I'm going to do 4 negative and then plus 3 and then square root. And then see, that's 1.73. Good one to remember there. So that makes a negative 2.26 is what that showed there. Now, if they wanted me to round to the nearest hundredth, let's say the 6 is in the hundredths place, so I need to look at the 7 and write that down, and then that's going to be big enough to round that up, so negative 2.26. So I'll do this one now, and so I'll clear that and do 4 negative, and then I do minus this time. I enter 3 and then take its square root and press equals, and there it is, negative 5.732. So negative 5.732. So this time if I round to the hundredths place, the 2 is not big enough to round that up, so I just leave it as negative 5.73. So those are my 2 roots. So let's take a look at one that's a little bit trickier. What's tricky about using this method is when we have to deal with the fractions. And so that's what we'll see on this problem here because we have an odd number. So it's already set up for us. So we can go ahead and take half that b term. And so that makes, again, negative 19 over 2. Okay, so leave it as that number. It's a whole lot easier than trying to deal with the decimal form. So now we're going to take that number and square it. So when I square it, and it's I think important for people who are especially going to go on in math further to memorize some of these perfect squares. So 19 squared makes 361. And then 2 squared makes 4. It just makes the math go a lot easier, a lot faster, and you can estimate things a whole lot better if you've memorized some of these perfect squares. Just like when you've memorized your multiplication tables, math goes a little faster. So now we've got this, z squared minus 19z, and then I'm going to add on this 361 over 4 equals, and then I've got, well, 66 plus 361 over 4. And so now I've got the factored form I'm looking for. So this is going to be z, and then minus, and then it was whatever half the b term is, 19 halves, quantity squared. Now on this side we have to add these. So we can multiply this by 4 over 4 and come up with a common denominator. So this makes 24, carry a 2, 24 and 2 make 26. And so when we add this together, we get 361 and 4. So we're adding the 361, 264. And that gives us 5, 12, carry a 1, and 6. So 625 over 4. And this equals, and then on this side we have that z minus 19 halves, quantity squared. Alright, so now we're ready to take the square root of both sides. So again, memorizing some perfect squares, it's kind of a handy thing. It just, again, makes things go a little bit faster. It allows you to not have to rely on the calculator so much. And here's what we end up coming up with. So the square root of the squared symbol is going to cancel out the square root. And we're left with a negative 19 halves, z minus negative 19 halves equals plus or minus 25 over 2. Square root of 625 is 25. And when we get to this stage, every single time, you know you're doing something right. You should always look for some of these things. When you have the same denominator. If you don't have the same denominator, then you made an error. Maybe you can reduce the fraction. That's a possibility, but you should have the same denominator already. So now we just have to set up our two numbers. So we have 25 halves, and we're adding 19 halves. And we also have negative 25 halves, and we are taking away, or we're adding the 19 halves. So we go ahead and add on the 19 and the 25, and that gives us 24. Carry a 1, that makes 44. So 44 halves, which makes 22. And our next one, we have to subtract these two numbers, and so that's going to end up giving me 6 and negative 6 of that, and negative 6 halves makes negative 3. So those are my two solutions here. So those are the types of problems that you're going to see on tonight's homework. Good luck.